Hi folks, we're going to take a look at page 376, number 16. Okay, so here they give us this equation which I represents the intensity of a note plucked on a string with respect to time. Okay, um, now if you take a look at this, you realize, well, this is really a half-life equation. So essentially what it's telling us is, because our base is 1/2, okay, it gives us a sense as to how long it takes for the intensity of this note to be reduced by a factor of 1/2. And we know that we find that number in the denominator. So essentially this tells us that it takes 12 seconds in order for the intensity of this note to be reduced by a factor of 1/2. Okay, and in fact, the first thing they ask us to do in part A is to determine how long it takes to have half of its initial value. Now let's say you didn't recognize this as the half-life equation. You could still solve it. Okay, you need to know how long it takes to get to half of the initial. Okay, so essentially your I at t can be replaced by half of the initial intensity, which is I naught. Okay, and notice how we can solve this problem without having a specific initial intensity. Okay, and the reason why we can do that is because you have the I naught on both sides of the equation. You can reduce that out. So you're just left with 1/2 equals 1/2 to the t over 12. So of course it's 1/2 to the 1. Okay, and again we've got that nice scenario where the bases are the same on both. So we just have that t over 12 is equal to 1, and so t is equal to 12 seconds. Okay, which is exactly what we had figured out just by observing the equation. So in part B, they ask us to determine how long it takes to get to 10% of its initial value. So here I'm just going to take the initial value and multiply it by 10%, which is 0.1. So 0.1 I naught equals I naught times 1/2 to the t over 12. Okay, and here again I can divide both sides of the equation by I naught. So I'm just left with 0.1 equals 1/2 to the t over 12. Here, though, of course, we can't get both sides with the same base, so this is where I'm going to take a logarithm to solve the equation. Okay, so I'll take log base 1/2 of both sides of the equation. Okay, so log base 1/2 of 1/2 to the t over 12. Okay, as we should know by now, when we've got inverse functions applied one after the other, we just get the original input. Okay, so here t is equal to, now since this is an application question, I want to be able to get an estimate for this answer. So I multiply 12 to the other side, and while I'm at it, I'll convert this logarithm into a logarithm of base 10. So it's log of the original input over log of the original base. Okay, and of course by that we mean log base 10. Okay, so let's do quick calculation here. Okay, so we got 12 times log of 0.1, okay, divided by log of 0.5, okay, and looks like we got 39.86. Okay, so 39.86 seconds is how long it takes to be left with 10% of the original intensity. Okay, next one I asked you to do was C, and it says here, suppose that the design of the guitar is improved so the sustain is increased. Okay, what effect will this have on the equation and on the graph? Okay, so let's think about it here. If the sustain is increased, it means we want it to take longer for the intensity to reach half its original intensity. Okay, so in other words, excuse me, we're going to have to increase that number in the denominator. Okay, because we want it to take more than 12 seconds. Okay, so essentially here, we have to replace this by some number greater than 12. So let's say replace it about 20. So this says that now it takes 20 seconds to get to half the intensity. Okay, meaning the intensity sticks around for longer. So the question is how, so this is how it would affect the equation. Okay, what you're dividing by there has to be increased, so something greater than 12. Okay, and how would that affect the equation? Sorry, the graph. So here, we can think of this as a transformation which is affecting the input variable. Okay, so we know that if we increase what we're dividing by, the effect of a multiplicative transformation on the horizontal variable is always the opposite. Okay, so here this division by 20 means multiplication of the x values by 20, which is bigger than 12. So what does this tell us? Now notice here when I draw the graph, I'm not going to bother drawing the negative side. Okay, so if this was my original graph, I'll call this one I2. Okay, if this was my original graph, I1. Okay, so what am I doing now? I'm stretching horizontally. And so by stretching horizontally, my new graph would look like this. So it still approach 0, but much slower. Okay, and it makes sense because as time goes on, we see that the intensity is higher than what it would have been under the original graph. Okay, so again, we can just consider that as being a horizontal transformation. Okay, that's it for this one.